Hello, my name is Lauritz, and I'm zooming in from beautifully sunny Aarhus in Denmark today to give you a brief overview over our FACT 2023 paper called Two Reasons for Subjecting Medical AI Systems to Lower Standards than Humans. This is a paper I've written with two co-authors. And over the next roughly 10 minutes, I'm going to give you an overview of the main context and arguments of this paper. I pasted my email address at the bottom of this slide, so feel free to get in contact if you find any of this stuff interesting. Okay, so the background for this paper is really the so-called double standards debate about algorithmic decision-making that we find in the current literature. And this debate is really concerned with the question of, well, suppose that you have a reasonably well-functioning decision system based on human decision makers. So that could be in a medical context where you rely on medical doctors for diagnosing or treating patients. The question is here, well, when you think about replacing these doctors with an AI system supposed to solve the same decision problem, as it were, what kind of standards should we hold these AI systems to in order for us to know that we are justified in relying on them? So here we just understand standards as normative requirements that must be met for permissible use. And in the double standards debate, we see that people take quite different views on what we should think of the relative standards for AI systems and humans. So some say that AI systems, for instance, in the context of transparency, must be equally transparent to humans in order for us to permissibly rely upon them, whereas others say they must be more transparent. So here's an observation that really frames the entirety of our paper. This debate about double standards as it has been conducted so far has mostly been concerned with the value of opacity. So for instance, Cirilli and co-authors has a 2019 paper where it is argued that we shouldn't require that AIs or AI systems are more transparent than humans in order for us to permissibly rely upon them. And furthermore, they say that we tend to overestimate how transparent humans really are. And in the same context, Kassir-Sadeh and Günther argue that we should, in fact, sometimes hold AIs to higher standards. We should demand more transparency of AI systems that we should demand of a human decision maker for making the same or solving the same decision problem. So the first contribution in our paper is really predominantly a methodological point. So even though the question of double standards could be seen as really broad, it has mostly been asked and discussed in the context of transparency, or the value of transparency, as we saw on the former slide. However, we could, in principle, raise, and perhaps we should raise, a similarly structured question for just about each value we hope decision-making to promote. So we could ask, for instance, for accuracy or for fairness or for equity, whether we should hold AI systems to higher or lower or the same standards as we hold human decision makers when they seek to address the same decision problem. So that's really the first point we're making in this paper. Perhaps we should broaden the scope of the double standards debate. And then the second point in the paper is more substantive, and we explore the case for double standards in the context of decisional accuracy specifically, or for the value of accuracy. And we do so in a medical context. And we find the surprising conclusion that we are sometimes justified in holding AI systems to lower standards than humans in order for us to permissibly rely upon them, which is quite an interesting and surprising finding. So first, to get to touch some common ground, what do we mean by accuracy? And here we mean something quite simple and straightforward. So let's compare a human doctor and a medical AI system that are both tasked with diagnosing a patient or a group of patients based on an input vector of symptoms. And here we just understand the overall accuracy of the relative systems, or the different systems, as the amount of true predictions they make divided by all the predictions they make. So accuracy is the fraction of all the predictions that hits the mark, as it were. So on this way of understanding accuracy, the question really turns into whether we ever accepted in using AI systems that performs more poorly than human decision makers in terms of accuracy. And we present two reasons for why this might occasionally be the case. So the first reason has to do with cost effectiveness, and the second reason has to do with speed. So the first reason, cost effectiveness. There is some evidence already suggesting that there will be AI systems that are less costly to implement and maintain than comparable human decision-making systems. So we cite some evidence from a study on diabetic screenings in Singapore. But even though the judge is still out on the precise cost and benefit structure of AI systems, we can still make the assumption that, or the speculation that some AI systems will possibly be more cost-effective than human decision or human-based decision systems. And the important point really here is that, well, if some medical AI system is much more cost-effective compared to a comparable human decision-making system, well, then all else being equal, then we can actually justify relying on this AI system, even though it performs worse in terms of accuracy than the human system. And why? Well, the thought behind this claim is rather simple. And it's perhaps easiest to see in the context of medical decision-making. If we accept a more cost-effective decision system, it means that we'll save quite a number of resources, and we would be able to redirect these resources to other areas, potentially resulting in more health for the same amount of money. So that would be one reason why we would sometimes have a reason to accept AI systems that are less accurate than human decision systems. A reason that flows from specific facts about the cost structure of having algorithmic decision systems. Of course, it's through and through an empirical question when these conditions obtain, but insofar as we can imagine that they will sometimes obtain, we have an argument for why we could be justified in accepting that our AI system is less accurate than a human decision system. So here's the second reason. Oftentimes, AI systems, medical AI systems, are much faster at arriving at their predictions compared to humans. And while speed need not always be that important, or at least the speed differential between humans and AI, it can occasionally be, specifically in cases where the opportunity costs of slow decision-making are very severe and the consequences of unnecessary treatment are acceptable. And we illustrate this in the paper by focusing on the case of sepsis. So sepsis is interesting because treating sepsis is very, very time sensitive. So in a paper, it is suggested that for every hour treatment is delayed of sepsis, there is a risk of death, increased risk of death by roughly 8%. And that is quite a lot. But if that's the case, that we have a decision problem where speed is very important, And occasionally AI systems can be more speedy than human decision systems, then we have a very strong reason to prefer AI systems, even though they are less accurate. So what's the underlying rationale here? Well, the rationale is that if the human decision system is sufficiently slow, then even though it will get some or more predictions correct than the AI system, the time sensitivity of the subject matter will imply that more people could actually end up dying simply because they are diagnosed and treated too late. Again, bear in mind that every hour of treatment delay for sepsis increases the risk of death by roughly 8%. So that could actually mean that we would sometimes be justified in accepting a less accurate system, provided it's much quicker in diagnosing people. And this is really what is illustrated in this figure. At time 3, we have death caused by sepsis. And at time 2, we have the time at which the human diagnosis is in. At time 1, we have the time at which the AI diagnosis is in, assuming here that sometimes the AI system could actually be faster. And there's actually some evidence showing this as well. Okay, so these were the 2 core arguments of the paper. And the upshots are really, well, first the methodological point that we raised, that the double standards debate as it has so far been conducted should perhaps be broadened to focus on other values than transparency only. And then we argue, and that is perhaps a surprising conclusion, that in the context of predictive accuracy, we might in fact sometimes be justified in relying on AI systems that are less accurate than human decision systems, suggesting that we are justified in holding AI systems to lower standards than humans. And this is quite a novel finding, because most papers focusing on this question, the double standards debate, has either argued that we should hold AI systems to the same standards, or that we should expect more, demand more of AI systems than we demand of human decision makers. Thank you for your attention.